Welcome back, everybody. Hope you had a really good weekend. Today we're going to be doing a little bit more in terms of circles, so more with area and circumference. So we're going to do a few lessons together in here, and then after this, I'm going to post a couple things on Google Forms in your assignments, which will just be more problems that are similar to this, because I don't want to give you anything new. I want to give you something as kind of review just to make sure that you can reference this to help you out when answering your problems that I assign later. So they're going to be very similar style questions. What we're going to really have to do is think about how to answer some of these problems in terms of the equations that we know. So we're going to be doing some examples out of lesson 18 here. And we're actually going to start with example 1, which looks like this. So we've got a semicircle with a diameter of 14 centimeters. So what we do know here, and let me actually rearrange our camera here so it looks a little bit nicer and easy to see. That's actually a picture of one that we'll use later, but I left some space up top. So we have a semicircle, and it doesn't have to be drawn the same exact way, but we know that the diameter is 14 centimeters. They want us to use 22/7 for pi. So we'll use 22/7 there. And then the last thing that we want to realize is that it's asking us to find the area of this semicircle. So we need to remember as well that the formula for area is pi times the radius squared. So if the diameter of this is 14, then what should the radius be? Well, if you look at this, we know that the radius is equal to half of the diameter. Therefore, in this problem, our radius is equal to 7. So now we're just going to plug in the numbers that we have. We have pi, which is 22/7. So our area will be equal to pi, or pi r squared. Pi is 22/7. And r is 7. So what is 7 squared? Hopefully you realize that 7 squared is the same thing as 7 times 7, and 7 times 7 is 49. I'm just going to write 7 squared as 49, or 49/1, because it is a whole number. Now we're going to do something here called cross-simplifying to make things a little bit easier. So we can look at the diagonals, and if they share any common factors, we can divide by that common factor. 7 and 9 both have a common factor of 7, so we're going to divide them both by 7 to make this 1 and 7. So now all that we have to do is multiply those two together to figure out what our area is going to be. Well, the denominator is easy. 1 times 1 is 1. So really what we're doing is 22 times 7. So I'll show my work up here. 7 times 2 is 14. 7 times 2 once again is 14, but we have another one here. So we've got 154. So our answer for this problem is going to be 154 centimeters squared, because we are talking about area. So the only thing is that that's not quite our answer yet. That would be the area of a full circle, because this equation here is when you're finding the area of a full circle. This is a semicircle. So in order to find the area of this semicircle, what are we going to have to do with that 154 that we got? Hopefully you're saying that we need to divide it by 2, because a semicircle is half of a circle. So when we take that and we divide by 2, we're going to get a final answer of 77 centimeters squared. So don't forget, if we're talking about a semicircle, we're going to divide by 2. Now we're not going to do the next example together, but if you look at the next example, it says it's a quarter circle. So we're still going to use the area formula there, pi r squared. It tells us the radius this time. But now, what number should we take our full area and divide it by? Hopefully you're saying that we're going to divide that area by 4 there. So we're going to do one more example together. And that's this example here. That's the one that I drew a picture for that I want you to start thinking about. Marjorie is designing a new set of placemats for her dining room table. She sketched a drawing of the placement on her graph paper. The diagram represents the area of this placemat, consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. So from here to here is 4 inches, which means that this is also 4 inches, and this is 4 inches. So if we have 3 4s, it means that the length of the bottom here, from here to here, is 12 inches. Now what you'll also notice is that it goes up 2 squares, and each square once again is 4 inches, which means that the height from the top to the bottom is 8 inches. Well, then it should be really easy to find the area of the rectangle in the middle. The rectangle is 12 by 8. We would just do 12 times 8, and that's going to tell us that the area of the rectangle is 96 inches squared. Now, we know that this length right here, from one end to the other, is 8. If that's the case, then this length from here to the center of the circle, or this length, is 4. That right there is the radius of the semicircle. Now, if we have a semicircle on this end and a semicircle on this end, it means that we have 2 semicircles, which totals a full circle. So let's break this apart into a rectangle and a full circle. Well, the rectangle we already know is 96 square inches. But what we need to find is the area of this circle here. We know that this length is 4 inches. And based on our last problem, we know that to find the area of a circle, we need to use the formula pi r squared. So we know that pi, in this case, let's see if it says to use 3.14 or something else. Explain. Doesn't say what to use for pi. So if it doesn't tell us what to use for pi, let's use 3.14. So we have 4, or area, is equal to pi r squared. And we know that pi, actually, you know what? Let's leave it as a symbol for now. So we'll say that our area is equal to pi times 4 squared. And 4 squared is 16. So I'm just going to rearrange this. It's going to be pi times 16, but usually we write that as 16 pi inches squared. Now, the reason I'm saying let's leave this as a symbol pi is because if we actually look at the next part, find the area of the entire placemat, explain your thinking. So we did that. We just have to add those two values together. And this is the key part. Assume that there is no waste. Now we've talked about that the pi symbol, while it doesn't always look pretty, it is the most exact form of pi that we can use instead of using 3.14 or 22/7. So we're going to leave that as 16 pi. So the area of the placemat, is 96 plus 16 pi inches squared. Now from there, if we wanted to find the area of 6 placemats, what would we do with all of this right here? Right, if that's the area of 1 placemat, we should take all of that and multiply it by 6 to get to our solution. So I'm going to show you real quick what that's going to look like. We are going to multiply all of it by 6, but this is kind of like when you're combining like terms. Because this term has a symbol, we can't combine it with this one over here. If it was just numbers, we could, but because we have that pi symbol, we can't. However, combining is adding. We're multiplying here. So we can do 16 times 6. Well, 6 times 6 is 36. And 6 times 1 plus 3 is 9. So 96 pi inches squared. But we're also multiplying 6 times 96 here as well. So we'll do that off to the side. 96 times 6. So 96 and 6, we've got 36. 6 times 9 is 54. Plus 3 is 57. So we'll have 576 plus 96 pi inches squared. Now, that's assuming that there is no waste. If we wanted to find something where there could potentially be a little bit of waste, we could use 3.14 for pi here, and then find an exact number, or a number that's actually measurable instead of 96 pi. But if you were to leave your answer like this, I would be perfectly fine with it. So I just wanted to talk about those two examples, and we're going to have some time to do a Google Meet tomorrow to try to answer any questions that you guys might have about that. I would recommend practicing a couple of these. So maybe looking at the quarter circle problem. If you're up for a challenge, maybe you want to try this problem right here, where we're trying to find the area of the rectangle without these two quarter circles in it. But those are the examples that I wanted you to look at for today. What I'm going to do is I'm going to assign a couple questions on assessment, and those questions are actually going to be from the problem set here. I'll pick like 2 or 3 of them for you guys to try out. And I really want you to look at the types of questions that we're looking at and how to find either area or perimeter, depending on what it is, of the semicircle or quarter circles or squares even, because we will have to know that as well. Come with questions for our Google Meet on Tuesday, and or if you want to schedule a Google Meet ahead of time, please do that as well. If not, good work today, and make sure that you get those questions done on assessments. Enjoy the rest of your day, guys, and we will see you next time.